All right, we're looking at topic 3. So advice on, first of all, known angles. If you don't know how to draw the known angle thing, we'll just do that very quickly. Sine, cos, tan. Start with pi over 6, pi over 4, pi over 3. That's 30 degrees, 45 degrees, 60 degrees. If you want to work in degrees, mostly in IB you work in radians. I go 1, 2, 3, 3, 2, 1. All the denominators are 2 of these, but there's square roots over the 2 and the 3.
I remember the finals.
Yeah. There's in multiple ways. And then for tan, you go 1 over root 3. Tan 45 is root 2 over root 2, which is just 1. And then this is root 3 over 1, which is just root 3. Yeah, they're them. I know, we did them by year 10 earlier. Okay, so there's a number of ways to remember it. You can just learn it off by heart. Remember, root 2 over 2 is, not root 2 over 3. Root 2 over 2 is the same as 1 over root 2, if you know your surds, so they're interchangeable. All right, so we have this question. First thing I notice is that this is a non-calculator question, but this is a fraction that is not in this table. So, and we're looking for something got to do with sine, so that's a problem. But not for long, because if we have the ratio of cosine, we can create the ratio for sine in any triangle, because we know that in any triangle the ratio would be the same. So we can just make an angle x here. The cosine is the adjacent, which is this side alongside the angle, over 4. So 3 over 4. And we can use Pythagoras' theorem to get this other side. Why do we need this other side? Because sine is the opposite over hypotenuse, and this side over here is the opposite. So we use 4 squared minus 3 squared is equal to the opposite squared. When you work this out, you get 16 minus 9, which is 7. So the opposite squared is 7, so the square root of 7 is the opposite. I did that quite fast because I presume you're able to do that much. So what is the sine of this angle, which I've gone straight away to? It is root 7 over 4. Okay, but I don't need sine x, I need sine 4x. That's a problem as well. Because double angles and quadruple angles and triple angles are not the same as single angles. You just cannot multiply this by 4. You cannot do that. If sine x is 7 over 4, you cannot multiply by 4. One of the reasons is, one of the many reasons you should recognize it's wrong, it's going to give you a ratio of more than 1, which it can't be. You never get a sine or cosine ratio of more than 1 just because of the way the triangles are drawn. Sine opposite or adjacent can't be the longest side. Non-cal. Okay, so if I see this, if it's any more than one angle, so any more than just sine x, I will look at my formula booklet for double angles. So 2x, 4x, 8x, I look for double angles. This is hard to see on this one, I know, but where's the... Okay, I'm looking down here, double angle identities, and I see something for sine 2x. So off that, sine 2x is equal to 2 sine x cosine x from my double angle identities formula. But this is sine 4x. So what would sine 4x be? Would it? No. It'd be 2 sine 2x cosine 2x. The only thing that's changed is you're halving this angle. So you're halving this angle either way. So half of 4x is 2x. That caught a lot of people up in this exam paper that didn't manage to get any further than this. Yes. I'm taking this is the identity. So there's no reason for the 2 to change in front here. The angle is doubled, but the 2 is not.
So will you double it again?
Well, we still can't. Yeah, we still can't work with sine 2x. We only have values for sine x and cosine x. We know sine x is 7 over 4, and from the question, We know cosine x is 3 over 4.
How would you write it if it's sine 6x?
They won't do that. Not at SL level. They'll do x, 2x, 4x, 8x. They're the ones because they are divisible by 2. Yeah, you'd have to do this would be 4x, and then you'd have to split that up, and then you'd have to split that up again. You're trying to bring double angles down to a single angle in order to work with it. If you have single angles at the start. If you have double angles at the start, you could substitute in, but we have single angles. All right, so I need to change this again. And this is where a 4 might come in, because this sine 2x is 2 sine x cosine x. So this is now single angles. That's good. Cosine 2x also needs to go to single angles. So I'll consult my formula booklet again, which you can't see, but you can use any of them for cosine to bring them to single. I'm just going to use the 2. You can't see it, but I'm going to use this one. 2 cosine squared x minus 1. This I think it'd be more than 5. It might be 8. Okay, so this is all singles. Is this a single angle? Yes. Remember, this can be rewritten, the cosine squared, cosine x squared like that. It's the same. So now they're all single angles. As soon as they're single angles, I can replace them with these ratios. That's what I wanted, to replace them with the ratios. So I have 2 times 2. Sine x is root 7 over 4. Cosine x is 3/4. So I'm just replacing with the stuff I know. Times 2 cosine squared x is 3 over 4 squared minus 1. And this is something I can now just work out and get a value for. It's not particularly easy looking, but a couple of tricks once again. 2 times 2 gives 4, and that'll cancel out with one of these 4s here. This 2 and this 4 won't make a half. Oh, no, it doesn't. Sorry, this is inside the bracket. That's bad. Don't do that. I have to square it first. Okay, let's just multiply it. Yeah, I could. Let's just multiply at this stage. This is still a 2. Root 7 times 3 times 2 times 3 squared. What does that give? Let's just do this bracket first because it's easier. That's 3 root 7 over 4 times, let's do this one separately, 9 over 16 and 16, so it's 9 over 8 minus 1. Okay, that makes it easier because this is just, what's this? 9/8 take away 1. 1/8. Okay, so I'll finish it off over here. 3 root 7 over 4 multiplied by 1/8. So that's 3 root 7 over 32. Okay. All right, so that's the first one. We'll do another one of these, and that's this one. This is harder again. Okay, this time at the start, they don't give a value for sine or cos. So you don't need to draw a right angle triangle. But at the end of it, you expect that you'll have to use that table we drew on the other page. So if you got nothing at the start, probably at the end you'll have to do the unit circle thing, which we weren't great at on Wednesday. All right, so let's figure out a way. If I see sine and cos, I want to get it down to 1. I don't want sine and cos. I just want sine or cos or tan. If I see sine and cos, sometimes I think tan because sine over cos is tan. But this one, I think I could, if I just change this one, I will be able to get it all in cos. If I just change that one to cosine, the sine squared one. How am I going to change that one? Well, there's no identity in the booklet other than which identity will do the squareds. Sine squared, which identity is sine squared in it? It's the first one. Pythagorean. Yeah.
The second one.
Oh, proven wrong. All right, so I noticed something here. I'm gonna move this, subtract this one from both sides, add this one over here, and I get sine squared x plus cosine squared x. This you got to recognize. What's that? What is it though? What's the value of it? You should recognize this from the unit circle, or maybe not, or maybe just look at your formula booklet. Why did I? Because I want to put these two together. I could have brought it all onto one side. It's okay. I just want to have it on its own. What do you think, James? It's the fit and identity that's there, yeah.
Oh, 1.
1, yeah. So cosine 2x minus 3 cosine x is equal to 1. Now at this stage, I see that this is an issue. That's a double angle, that's a single angle. Always get it back down to single angles using your identities. Which one will I use? Well, I want to stick with cosine, so I don't want the one with sine. So I'm going to switch this using the formula booklet. I won't put it on screen because you can't really see it anyway. But this is in the formula booklet, cosine squared x minus 1. We used it in the last question. Minus 3 cosine x. Actually, I see that this is going to look like a certain type of equation in a second when I undo it. So I brought the 1 back over by subtracting it. What is it? Oh. Oh, I've got a phone call. Right. Not from the wife, no.
Boy!
It's internet provider. Not quite as exciting as any of those things. All right. Yeah. Oh, so I see it is a quadratic. It's a quadratic. Because I got a squared, I got a single, I'm going to have a constant. Let's just tidy this up a little bit. 2 cosine squared x minus 3 cosine x, and this minus 1 make minus 2. I could solve the quadratic. This is a non-calculator again. I could solve this quadratic like this, or I could do something called a variable substitution. I'm going to say a is cosine x. Just to make this easier to look at. It's easier to look at. It's the same thing. I'm more used to solving like this. So I factorized out 2a is a times 2a squared. 2 and a 1, I think this needs to be a minus, and that is a plus. Yes, because it's going to make minus 4 and plus 1. Okay. Take these separately. 2a plus 1 is equal to 0, and a plus minus 2 is equal to 0. A from this one is 2, and a from this one is minus a half, but a wasn't a. A, of course, is cosine x. I just did the swap over here. I was just writing it short way. Which one is illegal? No. This one doesn't make sense. Cosine can never have a ratio more than 1. Yes. Why? Why not?
Because it's a circle. You can have more than one circle.
This would suggest if cosine x is 2, the ratio will be 2 over 1, yeah? So the adjacent will be twice as long as the hypotenuse. And the hypotenuse, that's not allowed, yeah? Hypotenuse has to be the longest side. All right, now we got to work with this. We got to work with this. Now what? Cosine is negative a half. What do I do?
Minus pi over 3. Minus pi over 3.
Go back up?
Can you explain why you turned cos 2x into cos squared x minus 1?
Yeah, it's identity. So the double angle identities in your formula sheet. Every time you see a cos 2x or a sine 2x, you go to those double angle identities and you use one of them. There's 4. Use one of them to suit the question. This one I needed to stick with cosine because I already had it. And cos squared is the one I picked. So the identities are on your formula booklet. You'll see them in, they're here. This is the only one with cosine squared in it. You can't really see it, but the other one has cos and sine, or sine. And this is the only one with just cosine in it. So that's why I picked that one. All right, so now this is the bit that we need a refresher on? Unit circle bits. Right. So there's a number of things to look at. We need to go this much around the unit circle, which means how much? 1 time around. 2 pi is 1 rotation, 360 degrees. I need to stop off at certain quadrants. Which 2 quadrants do I need to stop at? Well, all quadrants will have cos in it. Which 2 quadrants give a negative answer? So now I look at the negativity. These 2 quadrants have cosine negative. Why? Because cosine is directly related to the x-axis value. We've done that a few times. Why? Because of that right angle. That's sine is the y-axis, cosine is. So that's negative. Cosine is negative here and here. You can always, if you want to draw your sketch, all are positive here. Sine is positive there. Tan is positive in this one. And cosine is positive in that one. Okay. And if they're not positive, they're obviously negative. Okay, so cosine is negative here and here, here and here. What do I need next? I need my reference angle. So I figured out what quadrants, and now I need a reference angle. What is my reference angle? Where is cosine a half? And that's where I go back to that table I drew for the first question, which I put somewhere. I drew it in the first question, perhaps. So cosine a half, I look for it. It's pi over 3. Will you stick with pi over 3 if the question's in pi over 3? Okay, so my reference angle is pi over 3. Pi over 3 sits in this quadrant. It's 60 degrees. It sits here. That is not the quadrant I want because cosine is negative. So I need to use this quadrant. Anytime you need one in this quadrant, it'll be 180 degrees minus your reference angle. Anytime I need one in this quadrant, it's 180 degrees plus your reference angle. Anytime I need one in this quadrant, it's 2 pi take away your reference angle. Anytime. That's always.
So why is the angle pi over 3?
What ratio gives a half? So you have it here. Cosine that gives a half is pi over 6. Cosine that gives root 2 over 2 is pi over 4. Cosine that gives root 3 over 2 is pi over 6. These are the known angles from the known triangles. They're actually on the board there, those known triangles. That's something you got to know off by heart. So in these non-calculator questions, that's gonna come up. Almost certainly. Known triangles. You practice a few of them. Maybe when I give you the questions, you can. Okay, so reference angle. If it's this quadrant, I do take away pi over 3. So I'm going to take away pi over 3 and add pi over 3 for these 2. So common denominator, very quickly, to do a common denominator with 3, I just write 3 and 3 in front of this and this. 3 over 3 is 1. So pi over 3, take 3 pi over 3, take away pi over 3 is 2 pi over 3, which finally is our answer. We got an angle, 2 pi over 3. 120 degrees in that quadrant. And this one is going to be 4 pi over 3, our second answer in this quadrant. You need to work on those, you need to practice those. That finishing a question skill is difficult, but with practice, it comes automatically. By the time the day of the exam, you want to be sitting in paper 1, being able to draw that table correctly and getting to finish something like this systematically over and over again. A little bit, yeah.
I can draw the tables, but I just don't understand it.
It's when you come to an end of a question and they give you a ratio, a fraction, and you got to work back and find the angle. When they give you a fraction, cosine x, you don't know the angle, but you have the ratio, is usually where it's used. You need to see more questions and do more questions. Get used to seeing it. Okay, the next one is a bit more straightforward. Okay, so pi is this length here. What is this angle?
Length is equals to radius times theta.
Okay, so what did you say? You got a formula?
Yeah.
What is it?
Length is equals to radius times theta.
Arc length is equal to the radius times theta. Okay, so that's from the formula booklet. We know the arc length to be pi. We know the radius is 3. And we know theta is theta. So what is theta? Very good. Theta is pi over 3. Fantastic. It says it. It's in the question. No, it's pi. Okay, that's better. And then to find the shaded region, once again, go to your formula booklet. This is a very common question 1 in a paper 1 or 2. Just using those formulas. What's the area one? Half r squared theta, isn't it? Okay, so that'll give the area of the, well, we have pi over 3, so we don't need to. So a half r squared is 3 squared. Pi over 3 is our angle. Remember, that angle has to be in radians for this formula to work. It is a radians formula, and same here. It is a radians formula. So you get a half times 9 times pi over 3. 3 and 3 will cancel a little bit, so we get 3 pi over 2 is the shaded region.
What if they didn't give the arc length?
Is that right?
They can't do it.
Oh, right. Okay. My bad. You're right. The shaded one is the outside. So I found this one. So what's the?
You see the area of a circle minus.
Well, if we've gone this far, you can just subtract the. So what's the area of a full circle? Pi radius squared. Pi times the radius is 9, or well 3 squared, minus this. So this is 9 pi take away 3 pi over 2. You'd have to do a common denominator here. 18 pi over 2 minus 3 pi over 2. I didn't make put an equals. Is 15 pi over 2. Okay, I went about it the long way. The other way to do this is what angle would be the opposite angle to this? What angle's on the other side? So you have an angle here that's pi over 3. What's this one around the outside? 4 pi over 3. How would you get it? Wouldn't it be? No, don't get me to agree. So 2 pi take away pi over 3. So it would be 5 pi over 3, yes. Because this would be 6 pi over 3. Okay. All right, let's keep going. Yeah. You need it? Okay, good. Okay, so we have a function here. You're looking at, you should be okay at sine and cosine functions and their transformations based on a few IAs, maybe not. Okay. Okay. All right, can we continue? Okay, Isa, thanks. 2 minus 5 is this point from the question, and 4, 3 from the question is that point. We need to fill in a cosine bx plus d. In general, the number here affects what? This in front. Whatever's multiplying in front. It affects the amplitude or the vertical stretch. Well, we'll look at that in a second. What does the letter add? Anything added to a function will not necessarily. Will vertical translation. Up and down. There's not in this question, but if there was a cosine bx plus a c in there, or minus a c, probably minus c, what would that c affect? Horizontal, and going the opposite way to what you expect. And what does the b affect? It'll be horizontal stretch. But it also will be affecting the period of the function, how often it repeats. Okay. So we need to find all these values, A, B, and D, based on the vertical stretch. Okay, so for A, we're looking to find what the... Is it 4? Yeah, you're right. How do you know it's 4?
Max plus min divided by 2.
Yeah. So you could do max plus min, or you just look at where's halfway and how much above halfway is it. There's halfway, which is going to be useful later on in the question. There's halfway. -1 is halfway between 3 and -5. So how big the amplitude is, it's 4. So A is going to be 4. So we could start by saying 4 cosine. The BX we're going to leave till later. Or maybe we do it now. What's the B going to be?
4.
Every time I see this function, and I'm talking about the period of the function, I write this. Period is 2 pi over B. But that won't be the multiplier. That is the period. Yes. It won't be the B. It'll be the period. I write this. You have told me from max to max is 4, and that's correct. That's the period, not the stretch, not how it is stretched.
So it's the period divided by 2
So
pi.
4 equals 2 pi over B. So I've written in the period what you can read off the graph as the period. What is B going to be then? 2 pi divided by 4. Swap these two. So it's pi over 2, yes. So B is pi over 2 times x. And a lot of people will put 4 in here.
Why is it pi over 4 not 4? You divide by
Well, if you want, you can make this a 1 and cross multiply. So you'd have 4b 2 pi and then have to divide by that 4. If it's multiplication on one side and you do this cross thing, you got to divide on the other side. So write this. Anytime you see one of these functions, you're given a function like this. This b, right, period is 2 pi over b. Just write that down. And then put the period in, read the period off the graph, and then... Yes, guys. Yes, of course. All right, and now how much has it moved up and down? That's the vertical translation. I would look at the middle of the graph. The middle of the graph is normally where, Max? The middle of a function is normally where? Sine or cosine? Where is it normally? The middle of it. Normally, though, just normal sine function or cosine function. Where's the middle? At 0. So where's the middle of this one? No, where is it? -1. There you go. It's gone down 1. The middle. Look at the middle for that vertical translation.
I thought the middle would be the middle. What would that be called again? The middle is between the periods, right?
No, you're talking about the middle this way?
Yeah.
No,
No, I'm talking about the middle from the peak.
Oh, that's just half a period. There's no, yeah. I like the middle of the shape. Okay. 2 questions left. Okay, so we have a volume, surface area type question here. Show that, first of all, we got a, yeah, it's a pretty short one. Show that the radius of the cone is 3. So we got some information here. I think we're missing a bit. Yes. Okay. So if this much is 4 and the entire length is 3, this bit has to be 3, isn't it? Okay. So we can put that in. So that's the radius of the circle. Okay, so to show that, it's just 7 minus 3. If it's a hemisphere, 7 minus 3. 7 minus 3 is 4. Okay. Calculate the total volume of the ice cream. What would you do?
The volume of the sphere plus the volume of the cone.
Okay, so you consult your formula booklet. Volume of sphere.
Is it half sphere?
It's going to be half the volume of the sphere. So this is part B. Half the volume of sphere plus the volume of the cone. So the volume of the sphere in this case would be what? What's the volume of a sphere formula? It's probably up there somewhere on the wall.
4/3 pi r.
Yes. So a half 4/3 pi r cubed plus the volume of the cone would be
1/3 area of base times height.
1/3 base area times height. Yes. Okay, so the base area for a circle is pi r squared because it's a circular base, and the height is going to be, well, we just multiplied by h. Okay, so filling in the numbers here, the radius is 3 all along, 4/3 pi 3 cubed plus 1/3 pi 3 squared times 4. I can't remember this is a calculator question. This is a calculator question, so I can you just type that into a calculator and get 94.2. Part C then, if I want to find the slant height. So this is the slant height. How do I find this? Yeah, James, you're right. It's a triangle. So if I use this, it's if this is 4, this is 3. How do I find this side? Yeah. Okay, well, I've called this A. So A squared equals 4 squared plus 3 squared. A is going to be 5 when you work this out using your Pythagoras. You should. So that's 5. Find the total surface area. How do you find the surface area of this?
The triangle or the whole thing?
The whole thing.
Surface area of the cone plus surface area of circle divided by 2.
Okay, so we need the surface area of the cone.
It's like pi, let's say 1/3 pi r squared.
Yeah, what's the cone surface area? It'll be in the formula book and it's on the wall.
It's pi r L plus pi r squared.
Do we need to plus the pi r squared?
Yes. No, because you're not getting the circle.
Yeah, so this circle on top will not be included. So the cone surface area just is pi r L. L is this slant.
It's not the length of the whole thing down.
It's the slant height. Is L. H is the straight up height and L is the slant height. So there's definitely a difference between the two. And then the half of hemisphere, it's also up there. It is half pi r squared. I think that one it's right up. Surface area of a sphere, so half of that. All right, so this is pretty straightforward. The radius is still 3. The slant height we found to be 5. Oh, not equals. Plus half 4 pi. The radius squared is still 3 squared. Shove it all into the calculator and you get 104 meters squared. Okay. And part E, the ice cream is to be made from a lightweight polymer weighing this much per meter squared. Calculate the total weight. Yes. This 104 times the 1.23 will get an answer of 120. Okay. Not too bad, but remember to use those formulas. Sometimes we did them in the functions one where you had to maximize. Technically, that's not in this unit, so we didn't have to maximize anything. But often, if you look at the last video, you'll see where you have to create the formula, the maximize formula. That happens in calculus and optimization in functions. Okay, last question, bearings question. Which you're going to have to use sine and cosine. Before I do this question, there's a couple of things I'm not doing on this video, and that is the 3-dimensional geometry, which is the x1, y1, z1 formulas. So I'm not doing that one. That we did a question on Wednesday in class. So bear in mind that can come up. There's a few other things that can come up. Cosine rule and sine rule should come up in this question, so we're going to do that now. Your normal trig ratios we kind of did at the start as well, so pretty much everything done. Well, let's do this one. And this is a difficult bearings question. Okay, so trains A and B are 10 kilometers apart, so we're going to draw some sort of diagram where they're 10 kilometers apart. I don't know if that's 10 kilometers in a straight line, so I'm not going to predict it is. So I know that this distance is 10 kilometers. So, okay. It's pretty small, 10 kilometers.
Well, you said you don't know.
I don't, sorry, I don't, they're 10 kilometers apart in a straight line. I don't know if it's a horizontally. It's a horizontal line. Okay. Train A is 8 kilometers from, they're approaching the same train station, which is somewhere down here. Let's say the train station, well, let's have a look where first. Train A is 8 kilometers from the train station on a bearing 0.71. 71, so 0.71 is the 3 digits, so that means it's off north from the train station.
Isn't it 71 degrees through the... Yeah,
So I'm going to put the train station here because I kind of know where it's going to be, but in general, if you weren't sure, there's north, there's 71 degrees, well, that's a bit shallow. There's north, there's 71 degrees off north. That's 0.71. Does that make sense?
Yeah.
Okay, so it's always off north. So this, if this is the train station, this is A.
That's 1 degrees.
So if I have a straight north here, which I'll do off the train station, this one is 71, that's 71 degrees here. So I'm going to do the other thing off, and it makes sense because this is 296, which I drew. If I just drew separately, 296 will be all the way around to about here. On this. So what angle would it be off?
71 plus...
No, it wouldn't be 70. So just separately, if this is 296, how far do I have to go to?
360 minus 296.
Which is 64 maybe? 64?
Yeah.
64? Okay, so this angle 64 to B. Okay, so we've displayed it on a diagram. We want to find the bearing of train B from A. The bearing of train A, so this is north. From A, train B is somewhere over here. So I need to find this whole angle here. So let's start by, well, I didn't put in the 8 kilometers it said here, 8. I find this first, yeah, I find this first. How would I find that? Which one? Right, so this is a key skill. You have 2 angles here. This is a whole angle, we didn't call it, but that whole angle is 71 plus 64, which is...
Did the sine A over A and then sine B over B?
Yeah, so that's the sine rule, yeah. So you use the sine rule. Why do you use the sine rule? Well, you have 2, yeah, you have opposites, and you have 2 sides and 2 angles unknown. Now, unfortunately, this 8 is not opposite the angle we want, is it?
You use sine rule and you do it twice.
Yeah, well, you find this angle first, because it's opposite, and just, yes, and just minus it from 180. So 8 over sine at B, that's over here, is equal to 10 over sine at 135. A rearrangement of this is 8 times sine 135 divided by 10 is sine B. You get a decimal for that, and then you press sine inverse on your calculator. So you're doing the sine. Oh yeah, this is a calculator question. So you do the sine inverse on it, and I have the answer already. It's 30. Because you'll get a decimal. Well, we can do it. When you do this, 8 sine, so first of all, change your calculator to degrees. Mine's already in degrees, but usually you'll have your calculator in radians, but this is a degrees question. So 8 times sine 135, and then divide that by 10. You get a decimal. That's not an angle, that's the ratio. So if I want to turn that ratio into an angle, I press the sine inverse, the inverse operation, and put the answer in. I get 34.4. So B is 34.4. If B is 34.4, that's not the angle I'm looking for. What's this angle over here? 135 plus 34.4. Add those together and take it away from 180. And you'll get 10.6. That's 169.4. Okay, so 10.6 is this angle. What else do I need? 10.6 here. So I need the entire bearing.
Yes.
What is the entire bearing?
Yeah. You find the bearing, you find the angle just above that.
Yeah, you need to find, I think you need to find this angle. If I know 180 is to here. See that?
Yeah.
So if I need to find this angle, what is that angle? It's already on the diagram.
Oh, is it, what's that?
So I'll redraw it. We have north over here.
74.
That's 71. That's a 1, yeah.
71.
Yeah.
It's a Z, right? It's a Z.
Yeah, it's a Z. Yeah. 71 is here. 71 is here. North is north. North is parallel to north. So that's alternate. So what's the bearing? 180 plus 71 plus 10.6. Quick maths. 261.6 or 3 figures. 260. 262. Okay. Next question and last question. Train B is traveling at an average speed of 7 meters per second. Find in the nearest second the time it will take train B to reach the station. So we need the distance. We need this distance. How do we get this distance with the information we have? We can use sine rule or cosine rule to do it. Let's use the cosine rule. Let's use this side over here, x. Cosine rule from the formula booklet. X squared is the opposite two sides squared minus twice the opposite two sides. Cosine, which angle? This one over here, yeah. The angle in between these two sides, 10.6. Type all into the calculator, square root it, and you get 2.59. Right. Problem. This is 2.59. If I do, at a speed of 7 meters per second, what's the problem? Because it's kilometers. So I need the distance divided by the speed, but I need it both in the same unit. So it's 2590 multiplied by 1,000, yes. To change it to meters, divide by that speed of 7, and then I get meters per second, which is, I get the time, which is 370. I did it earlier. 370 seconds. And that's it. All right.